Now let's continue talking about the quality of service components. In this case, we're going to talk about shaping. Shaping means imposing a maximum rate. We are going to regulate queue and buffer on my traffic. So in order to achieve a maximum rate, I'm going to have this traffic pattern, which is really smooth. So this has the advantage of actually using all the available bandwidth that is permitted within this maximum rate. But the disadvantage is that in order to gain this smoothness, I will have to actually store some packets within buffers and make them wait and send them a little bit later on the wire. So that will increase the delay for some traffic flows. That will be the disadvantage. Remember that shaping is only available on egress. Now let's see how to configure it. There are actually two ways to configure shaping. I can, in both cases, I will use the same command, shape average, but in the first case, I can establish a target bitrate. This is given in bits per second. Remember, shaping is given in bit per second. And also, it will be an absolute value. So if I wanted to have a maximum rate of 1 gigabit per second, I will have to just write it down. Remember that this is bits per second. So that is actually easy to understand. If you see a target bit rate, it is an absolute value. But we also can use percent. Shape average a percent and then a number. That will be the percentage of a certain value. So this is actually a relative value, and the question is a relative to what value? And in traditional shaping, using only one policy map, that means in the cases where we are not using HQoS, hierarchical quality of service, if we are using just a parent policy or a single policy, this percentage is the percentage of the interface bandwidth. So for instance, if I had an interface bandwidth of, let's say it's 1 gigabit per second, if I use the value 30, this will actually be translated to 300 megabits per second. And the value 10 will be translated to actually 100 megabits per second. But because that will be the 10% of an interface that is 1 gigabit per second. And this will be the 30% of an interface that is 1 gigabit per second. But if my interface was a 10 gigabit per second interface, then a 30 will translate to 3 gigabit per second, and 10 will translate to 1 gigabit per second. So this is actually a relative value to the interface bandwidth. Now, if you are using hierarchical quality of service, that means that you have a parent policy that is calling a child policy, so to speak. So this parent policy may be shaping, and then you might also be trying to use percentage here. So if you were shaping in your parent policy, even though if you had a 1 gigabit per second interface, but your parent policy were shaping to, for instance, 500 megabit per second, then the percentage that you will be using within your child policy will be relative to this value. Not the interface bandwidth, but whatever value the parent policy is shaping the traffic into. I hope that makes any sense. So we have several types of shaping. This is what we have been using historically. Shaping per queue. So you will be creating shaping per class. We're going to see an example of this. So shaping per queue is the typical shaping. Remember that we are going to talk about Catalyst 9000 features here. So shaping per queue lets you have one class with shaping, with a shaping average command, another class with a shape average command, and another class map with a shaping average command, and so on. So this is just typical normal shaping. Now we have two derivations with hierarchical quality of services. We have per shaper and pairing using shaper. Per shaper is actually a really cool feature because, for instance, if you are connecting your switch to a carrier and that carrier provider tells you that you only have, for instance, 500 megabits per second, then the port shaper will make sure that traffic here will abide by this maximum rate. So it will shape all the traffic including voice, video, internet, database, transaction traffic to this max rate. And then you will be able to shape inside this maximum rate. So we are going to see an example of that. With parent using shaper, the shaping becomes a little bit more complex because you can shape per class here, but then you can call child policies after shaping per class. So this is actually a little bit complex. We're going to see an example of this. So remember, shaping per queue is the typical shaping that we have been using historically. Per shaper lets you shape all your traffic into a max rate and then call individual child policies and do whatever you want within this traffic. And you will be rest assured that the traffic that is going to be seen by external devices will be always abiding by a maximum rate. This is a really cool feature. I like this. This is cool. But pairing using shaper makes things a little bit more complex. You will be able to shape per class map, and then at each class map you will be able to call child policies. Let's see examples of each one of these. So shaping per queue lets me have a shape average command per class. So in this is the easier example because I only have one class, and within this one class, the shaping command. Notice that I am using an absolute value, a maximum rate. So in this case, I am setting the maximum rate to 512 kilobits per second. And this is known as shaping per queue because this class is assigned one queue. Remember that with Catalyst 9000, we usually will have 8 egress queues. So you might have 8 different classes, and each of these 8 different classes will get assigned one queue, and then you can shape the traffic at each of these classes. Let's see another example. This is also a shaping per port queue. So in this case, we have two classes. This is one class, and this is another class. So for this class, we are shaping, and we are using an absolute value. So the max rate for this class will be this, and the max rate for this class will be this. kbps. Remember that this is shaping per queue. So this, for instance, this class will get assigned a particular egress queue. So far, so good. Let's see now shaper per queue, but we're going to use percent now. So we have this class here, and then we have a video class here, and then we have a signaling class here, and then we have a transaction signaling here. So this means that given this is a shaper per port queue, this class will be assigned a queue, an egress queue, and this other class will get assigned a different queue, and this other class will be assigned a different queue, and this a different queue. So notice that we are using a percentage 10, percentage 20, percent 5, and percentage 30. So it will actually depend on the bandwidth of our interface in order to know what this percentage is referring to. So let's imagine that our interface is a 1 gigabit per second interface. Then this will be actually shaping the voice traffic into this pattern for 100 megabit per second. And then for class video, we will be shaping for 200 megabits per second, because that will be the 20% of 1 gigabit per second. And then for signaling, we will be shaping for a maximum rate of 50 megabits per second. And for transaction, we will be shaping for a max rate of 300 megabit per second, because that will be the 30% of 1 gigabit per second. So this is known as shaper per port queue, and this is the way that we've been doing shaping for years. Now let's see what happens with an example of port. This is an example of port shaper. This is a hierarchical QoS feature that is known as port shaper. So notice that we have a parent policy map, and in this case we are only having one child policy map. So within the parent policy map, in the class default, we are going to shape average everything. We're using a 10% of the interface bandwidth. So if we had 10 gigabit per second interface, we are going to absolute shape everything coming out of this interface to a maximum rate of 1 gigabit per second. Why? Because 10% will be of 10 gigabit per second will be actually 1 gigabit per second. So within this shaping, I will have video traffic, voice traffic, and whatever traffic I want. No matter what happens, or no matter what this service policy does, all the traffic coming out of this port will be shaped into 1 gigabit per second. So this is actually a really cool feature. In this example, we are calling just one child policy. We could we could call several. In this case, we're calling only one. And for instance, we are actually going to do policing here. So for instance, for boys, I'm going to do a policing of 20%. So this will be 20% of 1 gigabit per second. It will not be 20% of the interface bandwidth, but it will be 20% of the shape average previously done by the parent policy. So I will be using 200 megabits per second to police voice. And then, for instance, for class C1, I will be reserving a maximum bandwidth of 10%. So in this case, given we are already use 200 megabit per second for voice, which is a priority queue, we only have 800 megabit per second available, and the 10% of 800 megabit per second will be 80 megabit per second. And then for this other class C2, I am going to guarantee a remaining bandwidth of 20%. And we are talking about 20% of 800 megabit per second. That will be 160 megabit per second. And then we are having another class C3 here that we are going to guarantee a remaining bandwidth of 70%. We will be saying that this is 70% of 800 megabit per second. That will be 560 megabit per second. Remember that the queue, in this case, the queue assigned to voice is a priority queue, and I am reserving 20% of 1 gigabit per second for this priority queue. So I have 800 megabit per second here for everything else. And this is the 800 megabit per second that I am using for these calculations here. So it can become complex with port shaper, but the advantage of port shaper is that no matter what I do with these child policies, the traffic coming out of this interface will be always be shaped into 10% of the interface bandwidth. I hope this makes sense. Now let's see the most complex shaping feature that is known as parent using shaper. This is also a hierarchical QoS feature. In this case, I have one parent, and within each class I am shaping. So I have this class here and I am shaping. I have this class here and I am shaping. I have this class here and I am shaping. And for every single class, I am able to call a child policy. For this other class, I can call another child policy. For this other class, I can call a child policy. And I can, for instance, within this child policy, use the command set. So this is a little bit more complex, and it is available for you if you have really complex scenarios to do shaping. You can use pattern using shaper. That's it.